This is Regenerative Skills, the podcast helping you to learn the skills and solutions to create an abundant and connected future. I'm your host, Oliver Gaucher. So at this point, I think we all know that YouTube videos, social media posts, and blog snippets will only get you so far. If you really want to develop the knowledge and skills you need to live regeneratively, you need the thorough information in a full book. Through their diverse range of publications, New Society Publishers' books explore topics that are at the forefront of creating positive change in our world. From regenerative agriculture and permaculture to social justice and eco-conscious living, their books cover a wide spectrum of subjects that empower readers to lead more regenerative and fulfilling lives. So whether you're a seasoned environmentalist, a curious beginner, or someone simply seeking inspiration and guidance on your journey towards regenerative living, New Society Publishers is here to support you every step of the way. If you subscribe right now to their newsletter at newsociety.com, you'll be the first to receive sneak peeks at new content and get discounts on upcoming title releases. You'll even get an exclusive discount code on their first purchase of books, ebooks, or audiobooks. So sign up today at newsociety.com. Hey there everybody and welcome back. So as the importance of the water cycle to global climate regulation has gained attention in the last few years, I've also seen an emergence of voices working to explain the science and the details of the intricate workings and the contributors to the nuance of water cycles. Now, one of my favorites, and one that I've come to count on to consistently expand my understanding about working with water, is that of Ali Bin Shahid, an engineer turned permaculturalist based in Islamabad, Pakistan, working to capture the rhythms of nature through quantification. In his substack blog Regenesis, he writes about topics such as enhancing bioprecipitation through afforestation, mapping the rain plan for the Valencia region of Spain, how beetles drive ecosystem dynamics, and so much more. I particularly appreciate his ability to make important connections between small actors in the environment with macro processes in our ecosystem and the ways in which this knowledge can be put to use in our own lives. In this conversation, Ali and I explore his journey and passion around ecosystem restoration, how his background in engineering is opening up new possibilities by modeling landscape hydrology, new technologies that can be used to bridge scientific disciplines for new discoveries, and how these models can inform a new generation of water and climate-wise policy and incentive mechanisms. And so with all of that out of the way, I'll hand things over now to Ali Bin Shahid. Well, welcome, Ali. It's a pleasure to have you here today. There's so many things I'm looking forward to talking to you about. But why don't we start with the basics so that we can get an understanding of each other's backgrounds and such. Where are you calling in from? And tell me a bit about how you got into the line of work that you are now.
It's a pleasure to be with you, Oliver. I'm from Pakistan. I'm calling in from Islamabad right now. So my background basically is engineering. I was working with the defense industry in Pakistan for I did 12 years with that. My basic field was mathematical modeling and navigation. So I would model stuff for navigation, autonomous navigation for equipment. But anyway, didn't really like it. Didn't really want to work with with killing people stuff. So I left that job, and then I did a permaculture course in 2012. And it was like a sort of like an accident because one of my friends, wanted to do some tunnel farming stuff, food in tunnel farming setups. And he asked me to do a course on that. And I did a course in one of the agriculture universities in Pakistan. And by the time I finished the course, I told him, I'm not going to do this thing because the amount of chemicals and pesticides they spray on this 3 months crop it's like killing someone. So I can't do it. And he said, so what's the solution for that? I said, let me find the solution for that. And I was looking for solutions, and I heard about Amazon farmers who used to grow the three sister crops.
Yep.
I had just heard of it in a passing somewhere. I don't really remember where I read it from, but anyway, I started searching that thing. And then I heard Will Mollison's permaculture, and it was like, oh, this is what I want to do. So we took a small farm near Islamabad outskirts, and we started working on it. It was sort of like we were banging our heads here and there. And I was doing the permaculture course, etc. With all that thing on ground, and we were just two guys. It's sort of like unfortunate thing even though Pakistan is a very agriculture country, what happens is most of the people, they leave the suburbs for jobs in this city. So when you go to the villages and stuff, you don't find anyone to work for you. So we were like two people, and it was a whole farm, and he's also paralyzed. So it was effectively only me. He is paralyzed from his waist down, my friend.
That is a challenge in farming, yeah.
So he said, what do we start from? And I said, we'll just call it a land moving equipment when we need to, but we started off from composting. So we started working on the soils, and that's how we started from. So first 6 months, we were just dumping organic material, getting any organic material from anywhere and just dumping it in one of the pits that we dug for it. And it kept on happening. And I was doing all the handiwork and going, getting in the mud and stuff. Then we started doing the swales. You might remember this, in that initially in the initial years of permaculture, it was mostly sort of like a set of principles and philosophy.
Yeah.
There was not much engineering design in it, and that was my biggest gripe with it. Okay, so you understand this thing is going to work, but how much of this thing will work? How much of this thing will work? And this is how my journey started, and my mathematical background plus the permaculture I started. After that, we did that for 3-4 years. It was like sort of successful, not really earning, but we actually found out the good things about permaculture. So land regenerating and stuff, we saw that thing. I learned to read the land because I was also doing a Greek medicine diploma at that time. Because I had left the job, I had a lot of time, so I was doing that Greek medicine and all that. And in Greek medicine, you actually look at the physical state of the body, and then looking at that state, you actually look at what kind of medicines, what kind of things you have in nature, and you make a connection, and then you try to heal the body via those natural herbs. So, for example, there are dandelions, which basically grow in a waterlogged soil,
Mm-hmm.
and they're actually used for treating inflammation in the liver.
Mm.
So right away, I could see the connection. Okay, so waterlogged soils, inflammation in the liver, it could be vice versa as well. So
Sure, it's very
dandelion basically
analogous to sort of almost like a liver system in a wetland or inundated soils in the ecology as the function of the liver in the body. That's fantastic.
And that's how I learned to read the land. So I would see a dandelion or a reed growing in some trench or stuff, and I would start saying, okay, so this is probably a channel that's going in the land. And actually, the land we were working on was very, very dry, bone dry.
Yeah.
And most of the land here is arid, and it's mostly clay, very little organic matter in it. And then the cropping makes it even worse because then you even lose that organic matter. So very hard and very, very dry soil. But I was telling my friend that this is a water channel that's going under this land. And he would say, how do you know? I said, I can see these reeds and dandelions growing on the sides, and they can't grow except if there's waterlogged somewhere. So we had that land moving equipment, brought in some excavators, and told the guy to dig it. And he dug 4 feet, and then it was like a raging stream of river going under it.
Wow.
And the land over it is extremely bone dry. There's nothing growing on the land.
Yeah.
But there's a nearly a river stream going underneath it. So that was my first experience with that, reading the land, and also being in Islamabad helped in a way because I used to play in these mountains. So it was pretty wild when I was here like 30 years ago. I'm like 45 right now, so I've been here since I was 3 years old. So we would be playing in the mountains and foothills, etc., and we would see the different kind of plants growing, and I could just connect those things with. Once I started connecting things, I would remember, okay, this thing was for this thing, this was telling me this thing, and then I would just take my motorbike and I would just roam in the mountains in those days, like 2012, 14, 15, and just keep on watching the ecology and then seeing the ground condition on it and making connections, and then taking some of those plants and using them in scenarios where I had similar ground conditions and I thought that this will help. that was the start of the journey. But then permaculture didn't pay, so I had to switch over to my engineering job again for 3 years, and that was when I was working with the uh, s- bolting equipment, docking equipment. Anyway, it helped because it was most of the time it was sales and stuff. So I learned sales at that time. Anyway,
There's so many overlapping
that's
skills there, and to go from engineering to permaculture and reading the landscape, looking at indicator species, and then back to engineering, I'm curious as to how those disciplines and those lines of learning informed and enriched one another.
yes, you make an interesting point. My initially in the initial years as well, before doing engineering, I was a pre-medical student. I was doing medicine. I wanted to do medicine, but then for some reason I just switched over to engineering because I also like mathematics. So it was kind of like I want to do something which had mathematics and biology both in it, but I couldn't find any discipline in Pakistan at that time which had both of these things. Right now, there are certain biotech and things in which there is mathematics and biology, but at that time there was no discipline. So I did engineering, and I thought mechatronics is probably the most vast field which connects everything. So I can at least look at the systems in a systems engineer's point of view. So mechanical, electrical, thermal systems, and I could see all the connections. And same thing, and the bio helped me that permaculture actually brought that all together with the. And at that time, I was fortunate to get in a Greek medical medicine diploma. That also helped. Then the sales came, sales job, and I started reading people. Interesting thing. When I left my engineering job, uh, my family was like, "What will you do?" And I was like, "I don't know right now, but I'll figure it out." So one of my old teachers, he was my MMA and boxing teacher. We were sitting, and he said he was planning to open a club, and I said, "Let's open it in my neighborhood." He said, "Who will run it?" I said, "I'll run it because I'm pretty much jobless right now, so I can work in that." So I opened that gym, and uh, I had been doing boxing and MMA since my childhood. So now I also have a gym and stuff like that, and all of those things help in strange. They connect in strange ways. So I'm looking at someone, I'm reading the person, and I'm also analyzing him in the sense that, okay, so he has this problem. By looking at him, in Greek medicine, they also teach you how to look at someone and understand he might have some condition. Like looking at nails, you can read the liver condition. Looking at the tongue, you can understand, okay, this is the problem. This is some whiteness in his body or dryness in his body. There's an inflammation somewhere. And you also also reading the land in the same way, and you're also treating the guy, and you're also treating the land. So it was kind of like very, very, I would say, very strange journey for me till I reached this point where I am doing what I love right now, connecting systems, quantifying nature, trying to find solutions.
So tell me more about this, because as I spoke to you about before, I am pretty deep into the practical applications on landscapes and within, especially agriculture, for harvesting water on the land, managing and planting in a way that helps to retain and cycle water through systems, and then even look on a broader landscape scale to revive the hydrological cycle, the small water cycle and such. And you're looking at this as well from what actions can be done, but also through the systems modeling perspective. How did, first of all, you get into looking at it from that angle, and how this works out in your career, your pathway right now?
So what kind of farm are you working on, for example?
Well, I work with all types of farms, especially those based in this area of the Mediterranean in Spain where I am. And I have my own small project, which is 3 hectares with a river running right through it. And I'm involved in doing some restoration of induced meandering in the river and reconnecting it to its floodplain. There's so many things that can be done around here.
So yeah, basically when you, I divide it in 2 ways. So if you're looking to repair nature, you need a little bit larger scale and a little more variables in your landscape. First, so you would be looking at that landscape which is right besides the river, so riverine ecosystem, and then you would also be looking at some place which is around 500 to 1,000 meters, because you want the orographic effect to be used in a way that when the wind rises up, it can actually condense into form of forest, into clouds, And a forest at this location will help because it adds the extra moisture in it, and the moisture that the wind is carrying, it sort of the temperature decreases because of the rise of the wind. So you have a cloud condensation happening there, and you can have clouds there. But it depends on how much of an area you are looking for. As a rule of thumb, if you have more than, as a rule, it's a good thing to have something like 30 square kilometers. But even less, you can still work on that. You can still have some effects, but it will depend on other things as well. If it's a smaller area, for example, you will need a landscape which has all of these ingredients. So a low-lying plain and a mid-slope plain and a high 500-meter place. And you don't have any competing aerosols like the pollutants in the city, because when you have competing aerosols, they decrease the amount of vapor in the air by competing with it, and then you have a smaller droplets which actually don't condense in the form of cloud. They actually will form some haze kind of a thing, trapping heat and all that. So if you're looking at things which are, you're trying to repair a local hydrological landscape, you need a slightly bigger area. I would say at least minimum of 10 square kilometers to 30 square kilometers. That's a minimum. It's a good thing to be around 30 square kilometers. If you want the biotic pump occurring, you need even more than that. You need probably 100 square kilometers.
So obviously we're talking about scales that almost no individual has access to. Maybe in a couple of mega farms in Australia or something, right? So these by necessity are community level projects. They're probably government level coordination, right? So let's take a couple of steps back and go through some of these processes, these cycles that you mentioned briefly there, and get oriented to how they have interplays with what is happening down on the ground.
Okay, so let's go back to a smaller scale. So for example, you're on a small farm, like 2 hectares, like you mentioned, 2 or 3 hectares. The first thing you should be doing is you should be putting in some shock absorbers for whenever the rain event occurs. It's the same process with the engineering principle of damping the system, so that it doesn't fluctuate with the rain or any forcing element. So by damping element, you can have charcoal, biochar in the soil. You can increase the topsoil. You can have small wetlands. You can have small ponds. You can have swales. Anything which basically dampens the system, but dampens the effect of whatever forcing element is coming. You would need that. So in a very small setup, like rooftop garden, you would probably need something like small tanks and a little bit of surface which is not so hard. Maybe you put in some 6-inch synthetic turf or synthetic material which actually absorbs that moisture, absorbs that rain, let it trickle down in some.
So now we're talking about the general principle of knowing that there are going to be increasingly heavy rain events. This is the general pattern around the world, right? So longer periods in between rain events and heavier rain events when they do happen. And so you're getting surges on the system, and one of the universal things that can be helpful even on a small scale is anything that can reduce that surge, that can take that hit and hold those water resources to be spread out when there is no precipitation. Now, obviously, the application and the appropriateness of different possible actions and implementations are going to vary by a whole bunch of different characteristics. So, the texture of the soil, where on the landscape you are, the topography, the vegetation, all of these things. But as a general rule, things that can take that hit without becoming eroded, for example, minimizing erosion, and having a way to hold the excess so that it isn't lost and can be redistributed in dry times. Is that correct?
Yes, that's correct. You can also say you can also look at it, for example, in a more intuitive way. For example, you have a bicycle or a car, and you don't have any shocks in it. So the moment you hit a pebble or a stone or a rock, you will feel that impact directly at that time. But when you have a shock absorber or damper in a system, you can actually pass over it pretty comfortably. That's the same principle with the land. Of course, just like you said, that depends on the land that you're on and the scale of the land that you're on. How would you put that damper in it, that element? So it can be as small as a small piece of, even a sponge on a roof can be a damper in some cases, and it could be as large as putting like tons and tons of biochar on the land
Sure.
to
Or a system of ponds and terraces and key line,
terraces.
yeah, rips. And yeah, there's so many different possible, I guess, projects and systems to implement. But let's go back to some of the patterns in larger landscapes, right? So maybe you can clarify some of these terms like total water column and a lot of these meteorological or engineering terms that are not common for most people.
So basically, it's basically just telling you that there's a certain amount of humidity in the atmosphere, and it depends on where you are. For example, in tropics, you would want to have more humidity because you want to reach a certain dew point in the air, certain saturation point in the air. When you have that saturation point, it's easier to condense the water vapor into droplets. You need that kind of like the dew. You should be near the dew point. So in Mediterranean, it's around 20 grams per centimeter cube. That's in your area.
Sorry, say that again.
So it's about 20 grams per centimeter cube.
In this area of eastern Spain, Iberian Peninsula, you mean?
Yeah. In Spain, and it's about 20-21 grams. It's Mian also wrote volumes of work on this.
Yeah. His research has been instrumental to how I look at projects here. Yeah.
But if you are in Amazon, you would probably looking at 35 to 40. That's the number in Amazon. You go up in the polar region, it's about 5 grams. It's even less than that. So
it's essentially a desert.
Yeah, it's essentially a desert. But the condensation will happen even at 5 grams.
Yeah.
In a polar or tropic high region. So that's the first thing that you have. So you want a certain amount of moisture in the air. Now, the second thing in the picture is you need some condensation nuclei for that. But before that condensation nuclei, you need certain conditions. For example, what's the ground temperature and how fast the convection can occur. It's known as a CTP, cloud convection to convection. I'll just forget the name. Let me check. Sort of like, anyway, let's forget it. I'll remember it.
No worries.
So you need the clouds to rise and the vapor to rise and condense. The next thing that plays in it is how much energy is in the system to make this transition rise. To enhance, you also want the vapor not to leave the local system as well. So it should not be, in layman terms, if your surface temperatures are too high, for example, you are in a desert and you're introducing humidity via, some people would even go for as far as putting in evaporative towers. That's fine. You can put that as a stopgap solution before you have the trees. But then you also need something which doesn't have that lapse rate, the rate at which the vapor rise in the atmosphere, to be a certain value, which is about, for moisture, the sweet spot is between 6.5 degrees per kilometer to 9 degrees Celsius per kilometer. That's the temperature drop every kilometer.
Okay.
If it is around 6.5 to 8, that's a sort of like it's a good environmental lapse rate in which the clouds will form, they will rise, but they will not rise too much that you lose them to the higher cloud systems. And then the rain occurs somewhere else. It leaves your system. Maybe goes, you're working in Sinai and it goes to Italy.
Yeah.
So you lose that rain. So you want it remain in the same region. For that, you need to, I like to call these as acupuncture points. I'm still working on this model. It makes sense, but I have to simulate it, right? I haven't simulated this thing. But it makes sense that you should first start off with the places which have the higher surface temperatures. Try to cool them by wetland creation, by if it's near the river, like establishing riverine ecosystems. And then you lower that baseline temperature, then the lapse rate doesn't go as fast as 9 degrees per kilometer. Mm-hmm. You want that to be around 6.5, 6.7, 6.8. That's it. Maybe even 7 degrees per kilometer.
So let me see if I can catch up with this and repeat this back to you. You fill in the gaps in my understanding here. So as we have these heat pockets, many of which are caused by impermeable surfaces or lack of vegetation. This might be the heat effect or heat island effect of cities. It might be plowed fields. It might be just the natural landscape that's around there that is not able to cool very well. This creates high pressure systems as air is heated up and pushes moisture from the atmosphere into the higher levels, causing it to be lost into the upper strata of the atmosphere and go somewhere else. Am I with you so far?
Yes, yeah,
Okay.
okay.
And so on a
Then
practical level, some of the ways that you can do that is simply cooling down those surfaces, which are pushing moisture too high up into the atmosphere for it to be condensed and return within the same system.
Yep. So the third thing that you would need is you would need to look at places which are about certain height. For example, like 500 meters in your topography.
Okay,
That
500
helps
meters is
because
exactly where I am at. So I'm with you there.
so beyond 500 to even 1500 meters, that's sort of like a sweet spot in which when the air rises up, it will cool. And if you can add moisture at that point, you will have a lower dew point. You will have the condensation occurring at a lower height than, for instance, going at much higher altitude. So the cloud condensation, when it happens at this height, will form low clouds rather than the high clouds. But to enhance that further, you have that you're using actually that the forestation, the forest and the trees, etc. And they release bioaerosols. There's a small tweak which you can do before the plants establish themselves, and that's introducing fungal spores in the soil. The fungal spores can actually account for 50% of the bioaerosols. So if you have good fungal spores, then they don't require 5 years or 10 years or 8 years to grow. You can just use them initially.
Yeah, and spores can stay viable for a really long time too. They might have been produced a while ago, but they can still be active for a while.
As long as you have the moisture, they'll keep on.
Yeah. Yep.
They will keep on multiplying. So just have a small shaded area where maybe use tropical plants to just shade, or just any plants for that matter. Small wood, small shrubs and trees, and have a layer of fungal spores which are growing there. They will add that condensation nuclei. So you have a bioaerosols. So you had that temperature initially, a lower temperature. Then you had a height element, and then you have the third element, which is the addition of bioaerosols. This will, of course, depend on the area that you are in. For example, if you're living near a city, you have other problems at hand as well. There's a competition from other aerosols. And if there are other aerosols coming in, it will probably not condense into clouds. It will probably form a haze.
Let's talk about these aerosols for a second, because first you said bioaerosols, of which fungal spores can be a significant percentage. The rest of it, I assume, is bacteria that is emitted from vegetation.
Yeah, bacteria mostly. One of the most important bacteria in this is Pseudomonas aeruginosa. But Pseudomonas is also pathogenic to tomato and other crops. So it's basically ice nucleating protein, where it nucleates, forms ice clouds, but it's harmful for the tomato and stuff like that. So you would probably need a different kind of plantation here. You can't have maybe.
You have to be careful with cultivars that are susceptible to it. Sure.
Yeah, or you have
Sure, but it's not the only one. It's just one of the major ones, and this is
it's
emitted as part of the transpiration from the stomata of usually trees, right?
Yep, right.
Now, what do you know about the difference in types of trees and the amount of these nucleating bacteria that they're able to emit?
Off the cuff, I don't remember, because I have I have made some databases in which I can just look it up. But generally, you also have other bacteria which are not as pathogenic as Pseudomonas, not as efficient as well, but you can hit it somewhere in a midline where you can have the benefits of the ice nucleating or the rainfall inducing bioaerosols, but not have the pathogenic effect. That's one thing. But there are other aerosols released from the plants as well, which are like the monotropines and isoprenes and stuff like that, which also sort of like act as they recently integrated into secondary aerosols, which are like sulfate aerosols. They also act as cloud condensation nuclei. So it's a whole bunch of things. For me right now, the first thing that I do is if you're doing something on it, just check out the aerosol concentration, right? You can even look at it and see if there's haze forming or not. If there's a city haze, then you probably need some other plants to clean that thing first and then use the aerosols. But as a general rule of thumb, if you have some equipment to measure those things, you should be around 10,000 to 100,000 bioaerosols per centimeter cube. Not more than that. If you go more than that, it's dangerous. Then there's a certain size as well. So you need a 0.2 micron size for that bioaerosol. Lower than that, the droplet would be so small that it would probably not result in cloud condensation. It will trap moisture, but it will not be to that extent. Bioaerosol is still a topic which is considered complicated. But as we have more generative AI working solutions in this, we'll probably be doing the research that was being done in 10 years in 3 months and 4 months by building models. And I'm actually working on some of these things, trying to bring in insights from different models and then use the generative AI to build certain models which we can actually predict these things much faster, and then experiment. Once we have that things connected together, and then we can have a small workshop, small experimentation, which you can actually do it much faster than once you were doing like picking up each piece one by one.
This is super interesting. I want to come back to this, especially on how you measure these things and how someone can keep track and make progress in order to perform the types of experiments you're talking about. But let's go from the biological aerosols, which are potentially cloud forming by condensing water vapor in the atmosphere, to the ones that compete with them, the non-biological aerosols, their sources, and how this interrupts the hydrological cycle.
So one of the most notorious one is the haboob dust, the dust from the deserts. They are actually very hydrophobic, and the moment they are in the atmosphere, they try to stop any interaction with water. They even stop the rains from coming in. And when you would see the dust storms you have seen dust storms in the deserts. They have that haboob dust particles in them. And haboob is actually an Arabic word for storms. Haboob means is a small piece of dust, and haboob is a plural for that, which is lots of seeds, lots of dust particles. So when they rise up, they're known as a haboob, and we call them still the haboob dust storms. It actually means the same thing. Haboob is already dust. Right?
Yeah. And so what are the main sources for this these days? I mean, obviously there are very dusty landscapes that don't have a lot of vegetation. I struggle to say naturally, since so many desertified areas are man-made, but these days, where is this often coming from?
If we were to look at it in the sense of what's the most evil or villainous particles, they will probably not be the haboob dust, because as you rightly said, most of these lands are desertified. They're not actually deserts.
Right.
So they are just one source. But the other aerosols that we are releasing in the form of, for example, the carbon, microplastics, the xylene, the toluene, the pollutants from the industries, and all of those stuff, they also act in the same way as these things, and they are probably much more numerous and more difficult to solve than
sure, there's such a variety of sources from all of these things, yeah, and they seem to be exacerbating constantly with the complex addition of new chemical makeups all the time.
Yeah, and they are probably even more challenging to solve than the haboob dust, because you can always have some layer of grass growing over. You just provide moisture, and then you can stop and make buffers and stop that thing.
Right. And yeah, from my experience too, I mean, when we get into the contaminant forms of aerosols, they behave in so many different ways. I remember working with refrigerants, and those are generally heavy and don't like to go up into the upper atmosphere, but in big windstorms or in severe weather events can be transported up there. We're talking about the CFCs and stuff that have caused the hole in the ozone layer. So it's not just to the detriment of cloud nucleation. It's also so many other aspects of our atmosphere that are being destroyed through this.
Sorry. Yep, and you're right. And it's such a vast topic that it has so many nuances and so many aspects that probably it's very difficult to cover. But if you're working in a city and you are trying to create bioprecipitation, uh, you can work in a way in which you can have start off with the roads and have certain plants which are actually they trap these particles in them, and the certain which plants which can actually bioremediate them. I don't remember the names as such, but I have probably written a post on it, and it was probably 104 or 105 urban and peri-urban. I mentioned those things, and I can share it with you to look at it in more detail. But anyway, you can have those plants, and you can actually create wind patterns through air corridors by selecting certain plants and directing the winds in those areas. Let the wind take some of these things and direct them to those plants which can actually trap them. They have some waxy. These plants have some. Most of these plants have waxy coating on the leaves, and when these aerosols pass over it, they get trapped by those waxy coats. And when the rain occurs, they just go in the soil, and then you can have other mechanisms to other plants to actually remediate them or bioaccumulate them, whatever the case may be in that case. But it's a topic in its own right, and it's a huge topic.
It is, and I find it fascinating, but at the same time, it seems very theoretical because, turning the knob on concentrations in the atmosphere is not a process that we really know how to control right now. If we did, we probably wouldn't be doing half of the detrimental things to it that we are. And so where do you go from these theoretical models, these larger patterns in the atmosphere, and these very complex interactions between industry and aerosols and vegetation and all of these into something that we can take action on for a film policy?
It's a very interesting question because I was reading this study about Amazon rainforest, and Amazon rainforest actually, when the rain occurs, it actually scavenges all of the aerosols in the atmosphere. So even if the rainforest, for instance, is near a city and there are a lot of pollutants coming in, but because of the sheer size of the rainforest, it creates rain, and that rain scavenges all the other aerosols. And when that thing is occurring, the stomata are also releasing more bioaerosols. So it's removing those polluted aerosols and by releasing the other aerosols, and the spores also release at the same time when the rain occurs. So the nature is sort of like telling us that a way to do it is you have those green corridors, and as you have those green spaces, at least 30% of this, for example, in a city, you can actually start changing the patterns in which the plants will actually start scavenging those things by rainfall, by creating their own rain. And that scavenging will actually stop that effect. And as you have more and more of these green spaces, and you can actually tailor them by use of microspores, by the fungal layer. So you don't really need to have trees in every place. You can have some fungal spaces just to enhance those aerosol concentrations for that extra condensation nuclei. And you can also have, there are certain other interesting, I think they're pretty interesting allies in diatoms, the microalgae, which can be very easily adapted for rooftop systems. It releases DMSO aerosols, which are sulfate aerosols actually, and they're even more efficient than the other bioaerosols in creating rain. Plus, the diatoms can actually, you can use them in a wetlands to take care of the pollutant loads, which is in the sewage and all of those things. They convert that into diatoms, and they release all of those things, produce food, and provide basic nutrients for other plants, other animals, other species to eat. It's not, I would not say this is a one kind of solution for every landscape. So you would need every natural element, every natural thing which can enhance a certain factor. I believe that nature has all of these things in place, and man as a steward can actually use those different solutions in different areas and connect them together to recreate a society in which we have regrowth, and all of these cycles can be repaired. And we can repair it much faster than we destroyed them if we can correctly model them. And fortunately, because most of the things are occurring right now in the AI space at a very fast pace, most of these connections can be made in months rather than years and decades, which was like even you just go back 3 years ago, it was unheard of that AI would be progressing so fast. And with these AI models and this natural system that we are already in place, we can actually connect those together and actually find out the exact quantifications for doing certain things.
So you see AI as being a real asset to these complex models and systems models that you're working with now.
Yeah, I think of it as an asset because when you talk to different scientists, most of them are experts in their own fields, and that's absolutely fine because you need experts. But most of these experts are disconnected with the other aspect. And when you are trying to form a solution, like you are an engineer, you would know that. Engineers try to take up things, they take up formulas, they take up solutions, and they merge them together to integrate them together to form a bigger solution. So you have the scientists and you have the philosophers and you have the permaculturists, but you need people who can actually connect all of those concepts together, quantify them, make solutions. And AI can help that because AI will help you or me, people like me, who are not actually scientists per se, but we are modelers or system engineers. We can actually take up these components, fit them together. Okay, this fits, this works. Let's try it.
Yeah. So you see it being a real bridge between disciplines and specialties in order to increase the communication and the range of potential connections?
Yes, I see it in that way.
Okay.
Plus, there's another issue, which is basically the data. You need data for what all of these things, and AI can actually have those. You can have synthetic models which can actually generate that data, which is when you run them and you see you use that data for it, and you have that historical data with you as well. You can generate the synthetic data and see how it behaves and compare that with historical data. If it's the same, that means your model is working correctly. And then you can use it for simulations and future projections.
Yeah. I definitely see that. This is not a world that I'm well versed in, so I'm kind of piecing together the ideas as you're saying them. But I want to go back to another point that you made there too, is that there's a potential to fix the systems that are currently broken much faster than we broke them. And these different ideas are something that you regularly explore in your blog, the Regenesis Project. And I'm wondering if you can point to some of the projects or the evidence that you have that supports this claim.
Okay, that's a good question. Generally, when I'm even in writing in the blogs, I pick up some already research study, which is a meta-analysis or something like that, which has already been proven. So people have, for instance, let's say there was this project by Branch and Wolfmeyer in Muscat and Oman and Israel, in which they did a desert plantation of 100 square kilometers. And they saw that this desert plantation, they chose a time in which there is no weather system entering the area. So it was a peaceful time in terms of weather. No systems are coming in. And they found out that they could actually increase rainfall by 20% by having a certain mix of species, and a certain mix of those species are releasing those. And then they gave us a model for. Interesting thing was this, another point. They did the same model in Israel and the same model in two places. So one is in Israel and the other is in Muscat, Oman. The Oman one was having extra rain, but the Israel one didn't have. But then they found out that it's basically because of the cloud convection potential. So Israel had much lower surface temperatures than Oman. So even if you have even a very low temperature, that's also harmful. You need a certain level.
So if you're in a cold region, these types of interventions are going to be less effective, is what you're saying.
Yeah, or you would need to increase the surface temperature by using certain plants which can actually, like for instance, jatropha. They use jatropha. When there's heat, it actually stops giving off ET, and because of it stopping the ET, the surface temperature rises up. So you can use certain methodologies like that.
Interesting.
You will find a solution in the nature if you look closely enough. But my point
Definitely.
was basically this. My
Yeah.
point is basically this. You find one of any study which has already been done by scientists, and they have that 3 or 10 year study. You find that study, you model that study, and you find another study which is maybe just connecting soil with it. So they were just connecting the atmospheric processes. You find another one which is doing the soil connection, and then another one which is on water, and then another one which is on rivers. And you just connect them as Lego blocks together. Okay, so this is proven, this is proven, this is proven, this all of these four parts are proven. Just let's connect them all together and see what happens. That's where the AI can help, because it can fill in the missing gaps in the data. If you have a good synthetic model, you can make a good model, and you build those gaps, and then you can check in an AI model or a generative AI model with the climate models, current models, in conjunction with that, and see what happens. Then you take that model in a real world and do a small experiment on maybe it's a 10 hectares farm, 10 hectares of area. And of course, you will have to do it in different places for different parameters, for so an arid zone or a desert zone or a tropical zone. But you get my point. Basically, you just pick up those studies which are already proven studies, and then use them as your baselines, rather than doing it completely, reinventing the wheel and trying to find out what will happen if I put this much moisture in the soil.
Yeah.
Just take out.
So I'm following what you're saying, and a couple of things are coming up. One is, have you found the necessary coordination with people who have jurisdiction or sway over the size of land that is required to start to affect things on a regional scale, interested in these models and the information that's coming out? Or is there a gap right now in between that communication?
There is a little bit gap, but I am actually starting to get some traction in that space. The moment you start getting the investors and people who are investing in these things, they get interested in this thing, then you can start getting that gap filled. So fortunately, some of these people are actually interested in building these models further and checking in them out, and they have the money. So I'm hopeful in the next maybe 6 to 8 months, I'll probably be in a better position. And there are a lot of other people who are working similarly in the same space, and I'm getting in touch with them and getting to know them and getting their work, and hopefully it will be much better, I think, in 6 to 8 months.
What would an ideal project that you would like to be involved in look like? Where do you find the excitement and the potential in what you're doing, what you're modeling, and maybe lay out what an amazing opportunity would look like for you in this realm?
So basically, I would say there are three regions right now which are very interesting, and there's one which is sort of like people think it's sort of like impossible. Generally, people think. So the three regions are the Mediterranean region, California, and the third one is where I live, Pakistan. Because I say Pakistan because Pakistan has like very little forest, and it has one of the best topographies in the world. It has Karakoram, K2, which is nearly the height of Mount Everest.
Mm-hmm.
And it also has -20 sea level places. Karachi has some places which are even lower than the sea level.
Yeah.
So it has all of those places. And to top it off, we don't have any forest. So anything that we do here, we are on the third pole of the earth. The most glaciers in the world are in Pakistan. If any modeling that is done in this region will have far-reaching effects, because it can be used in any other environment, because we have all of those things, from deserts to polar ice caps and all of those things, glaciers and all. So that's a very opportune space, but unfortunately, Pakistan right now is in other messes, right? So just leave it at that. The second most important place right now is the Mediterranean, because of the obvious reason. It's facing droughts. Spain is the breadbasket of Europe, along with Ukraine, and Ukraine has those Russia-Ukraine war stuff going on. So I see that there would be some effects on food production. Similarly, with where there's Italy as well, and all of these places are facing the changing climate effects. I'd rather call it the broken cycles effect,
Hmm.
because the small water cycle and all of these were disrupted. The second place, and the third is the California. An ideal project for me would probably be something like I did the post of Valencia, enhancing the rainfall in Valencia.
Yeah, I really enjoyed that one. And the series that went deeper into the different recommendations and what the models kind of imply for actions on the ground.
Yeah, I'm basically doing another series on that. It's going to be much more deeper than that, because as I write, I also learn more and more. So it's like a cyclic process. Sometimes I write and I realize that after some days that now I know more than when I wrote this thing.
That's great. That's that's an ideal process through a blog. I would imagine too that it sparks conversations from other people who
Yes, that's how
bring in
I learn.
other ideas.
Yes, sometimes they're very interesting people who make very interesting comments. And when I research those comments, I realize that, okay, I missed something.
Yeah. Yeah.
Okay, sorry. Give me a second. I need to put a charge on it. Can you pause the meet?
Yeah, no
Pause it
problem at
for-
all. All right, so you were outlining one of your ideal projects after talking about the different areas of interest.
So one of the ideal project would be probably somewhere in Spain. And there's a very interesting area as well, which is the Namib Desert. It's sort of like, it intrigues me a lot because of the fact that it's nearly impossible to do anything there. And it's like the oldest desert in the world. So it's like a 50 million year old desert. So the Namib, let me try to explain how the Namib Desert is. So you have, it's on the lower end of the Africa. It's a sliver of a desert, very thin, but it goes the entire coastline of Namibia. Historically, it has been known as the graveyard of the ships. The southern ocean brings in cold currents, and the wind that comes from there is really very cold wind, which has moisture in it. But from the other side, South Africa side and the Madagascar side of the Africa, winds come and you have mountains at that end. They rise up, they lose all their moisture, and there's no forest in between from that point onwards. So because of the losing of the moisture, the wind becomes extremely dry and very hot passing over the desert. And these winds that are coming from the other side, they are very cold and moisture-laden winds. Now, when they intersect together, the hot winds actually force the cold winds not to rise up. So the cold winds, they stay downwards and they form fog. So the Namibian desert is foggy like 100 plus days. It has very little precipitation. It rains about in 5 months, 5 years, once or twice in 5 years.
Wow.
So it's interesting because I think this problem can be solved, but it will probably require some ingenuity. Like you would
Maybe fog harvesting.
Yeah, you would need fog harvesting, but you also need some process to stop the high wind or make it go a little bit higher than what's it going. So maybe some ridge forest on the other side of Namibia, and then you also need to somehow raise the temperature of the wind from the cold front coming in. So maybe some diatom farms, seagrass farms, mangroves, which can actually rise the temperature a bit than from the extreme cold temperature it's coming.
Right.
That's a very interesting project that I think of and would love to do something like that. It's probably not going to bring any money or anything, but it's more of like a challenging problem.
But what I'm getting from this is that there is a potential in the near future for us to build a clear enough understanding, not only of the macro patterns that bring in precipitation and that move different weather patterns around continents, but also how our current actions and contamination are contributing to, well, the breaking of these cycles and how we can reverse these. So playing this out, what you're talking about through maybe small regional experiments at the moment could lead to a point where there's enough understanding and global coordination that we could actually, on a large scale, reverse the damage that's been done and get ourselves out of the climate mess that we're talking about. Is this also the potential that you see?
Yes, I definitely see this. I am actually, people get hopeless, but I am very hopeful that if we keep our heads straight, we don't lose ourselves to hysteria and stuff, we can actually find those solutions and we can do it much faster than we broke those cycles in the first place. Of course, there are certain tipping points. You don't want to reach them. But before reaching those tipping points, for example, if Amazon is deforested, it's going to be very hard to reverse.
Yeah, it's not just going to come back on its own. Yeah.
Yeah. But before those tipping points, those we can actually repair them.
Yeah. And so, what do you think is the most important general knowledge that is not currently present in the population that would be required for citizen action, the kind of changes that are required to make a different trajectory for our climate, for the health of our ecosystems? Is there something you would introduce into school curriculums, or is there just general knowledge that you wish more people had?
Yeah, it's a very small thing, but it basically explains the concept of the damping. And I think if someone understands the concepts of damping and how to shock proof from these events, even in it helps in any way. So the first thing I think people should be doing is teaching their kids and in universities how to rain harvest on their roofs and stuff like that. That's something which anyone can do in any landscape, in any place of the world, and it gives them the additional water, which is a sense of life. And that's the first step. Before any regulation or policy occurs, before any carbon taxation occurs, the government should actually empower people, give them those solutions, help them to establish those solutions on their rooftops. And once people have that extra water, in most of the places in the areas we live, we are always short of water. And once you solve the problem of water, and it's interesting, the water is enough for the entire year in most of these places. But for example, in Islamabad, it's 59 inches of rain, 49 to 59 inches of rain.
That's
If I harvest on my roof, I have enough water for the year.
Yeah.
But I don't do it. I do it, but not in the sense I'm saying most of the people don't do it.
Yeah.
And then the governments and the policymakers, they say you should stop using water. It's not stopping using water. It's not saving water. It's actually harvesting water in the first place. Once you start harvesting water, then the next stage comes in which you start appreciating saving water. If you save water and don't harvest, it's like kind of...
It's just austerity.
Stupid. That's just stupid. It looks stupid to me. It's stupid because I'll tell you why. For example, in the housing society I'm living in, the rainfall that falls here is 100 times more than the usage of this society.
Wow.
So if you stop people from using one drop of water, you're still saving only one glass. And if you just harvest that water 50%, you are increasing it by 50-fold. So that's why I say it kind of looks stupid to me that you tell people to save water, but you're not teaching them to harvest water from the rain that's already occurring. It's going in sewage. It's running away. It's just wasted.
Yeah. No, I totally agree. The public policy on dealing with drought and other water emergencies is very inverted from where the actual potential is, right?
Yes, definitely.
Yeah. And beyond that, I mean, let's face it, the biggest land managers, the people who could coordinate and make these changes on the landscape that could start to reverse the degradation of hydrological cycles are farmers and foresters, with a few other exceptions, but that's the vast majority of land ownership around the world. What should they be aware of? What's the knowledge that you would want them to have in the power and the options that they hold? Let's say water harvesting is already in there.
Yeah, I know. It's sort of like it's a huge question. But if I was to answer this thing, I would probably maybe just start reading the land. The land will tell them the answers. If they are trying to grow, for instance, cotton in some place, and the land doesn't want the cotton to be there, you can actually see similar species if they're growing there. And you're putting cotton there, you will basically disrupt the ecology of the land. You will have to bring certain things by yourself, i.e. the nutrients or the extra water or the extra things. So maybe just start reading the land. The land will tell you what you need to harvest in a certain place. And that's probably the first point that any big landowner should be looking at. And then the second thing is, monoculture look more productive, but once you start seeing things in vertical succession, you will start seeing more production. You will have more production in your land than from a simple monoculture.
Yeah. I really like both of those. That to me is the most important and gets the least attention out of the conversation on regenerative agriculture, which I'm a part of constantly, is just the idea of growing what grows like a weed in your place. And instead of looking at market forces and what there's a market for, look at what the land wants to grow. And if you think that there's more potential there than what is currently present, then you can look into how to accelerate the succession and the health that creates new opportunities that may not be there when you find it, but not imposing those before working with what the ecology already wants to produce. And then, like you said, beyond that, just a humility of understanding where you are in the cycles and progress and the succession and such, and working with those in each one of those strata and levels to work beyond what productivity looks like from an industrial standpoint, which is ecological control, and embrace the concept of stewardship and collaboration, which is always a multi-level thing, right? Love it, man. Look, this has been a fantastic conversation, and I can tell that there's so much more that we could go into, and I am closely following the blog posts that come out. I can't wait to see more around this one on Valencia, which is very close to me, and I have clients in that region and other parts of Spain. And ideas like this and the potential of regional and even national collaboration and coordination for these is just super exciting for me. So I will continue to look out for the new blog posts on the Regenerativist project, and I look forward to continue a conversation with you in the future. Can you please tell our listeners how they can get in touch with you and find more of your resources before we go?
Yeah, my Substack, Regenesis, R3GENESIS.substack.com. You can also find me on LinkedIn, Ali Bin Shahid. You can just search Ali Bin Shahid. It's the same name, LinkedIn/IN/Ali Bin Shahid.com. And that's it. There's a third thing as well. I have a small startup as well on the same thing, water. It's known as PSKL, Pani Sabke Liye, Water for All. We basically do this, the keyline. We have the keyline understanding, but we use it in a modified way, and it's basically a methodology for converting deserts into rainforest. But anyway, it's for some other day. You can check it out at www.psklglobal.com. PSKLGLOBAL.com.
That's super exciting. Well, look, thanks again for making time. I look forward to being in contact again soon.
Thank you, Oliver. It was a pleasure talking.
Now, before we wrap this up, just remember that these episodes are only the beginning of the learning resources, design and coaching services, in-person courses, and interactive community that are available through Regenerative Skills. The Discord server is our free community where you can connect with other like-minded listeners, exchange ideas, stories, tips, and resources, as well as interact with me directly and quite a few former guests from this show. Our Instagram account at regen_skills is the best place to see the projects that me and the team are working on, both for clients and collaborators, as well as on our own properties. I'll also be announcing the certification courses, workshops, and gatherings that we've got coming up later this year. If you're interested in getting dedicated support for your own project, You can now schedule a free planning session with one of our team members through the request form on our website. You can also find all the links, show notes, and past resources there at regenerativeskills.com. We truly believe that no matter your experience, your knowledge, abilities, resources, or background, you can be a powerful force for regeneration on this planet, and we're here to help you find your path. So as always, remember to keep taking those little steps every day towards a regenerative future, and I'll be right by your side along the way.